Hey, what's up guys, welcome back to Eureka, and in this video we'll be solving the pure math revision sheet for the periodic week 5. Now, two things before I start actually solving. This Saturday, me and Hassan from 11SA, we're hosting a teaching session for this periodic in the video conference room from 11 to 1. Of course, following along this video while I solve those problems will help you, obviously, but for those of you who are in IC Sharjah, please come to our session because we'll be solving more examples and we'll try to, increase the average this time, not like last time everyone failed. Anyways, the second thing before I start solving, most of you, I don't think any of you know what derivatives even are. You're just taking derivatives, learning rules, but what do they mean? So I'm going to take 5 minutes to just briefly explain what a derivative is. Okay, so before I do activity 2, let's see. A derivative of a function, let me just draw my coordinate axis. This is x and this is y, and this is your function, right? The derivative is the slope of the tangent line to this function. So if I have a line, say at this point, I want to draw a line such that it's tangent to a curve, right? This is, I think most of you know it already, this is the derivative, the slope of the tangent, so the slope of the tangent. But some teachers will use this notation. If this curve is f of x, then the derivative is f prime of x, right? If this curve is y, then the derivative will be y prime. Other teachers, or sometimes, they use the notation dy over dx. Now, I think you understand what this means, and that means they're the derivative of the function, right? But this looks like a fraction, right? Why are those two notations even related? I'll tell you why now. We're trying to find the slope, right? And originally, in grade 7, we find slopes for example, this line, right? We take 2 points, right? Get their rise and run. This is the rise, delta y. This is the run, delta x. So the slope is delta y over delta x, right? Now, if, however, we're looking at a function that curves, and you take 2 points, for example, we could do the same thing. We join those two lines by those 2 points by a line, right? And then we can find the slope of the secant line. In this case, this will be delta y, delta x, right? And however, this is not the slope of the tangent line. So what you have to do is we bring this point towards this point. So the slope will be something like this. There are actually 2 points here. You have the red point, and then you have the green, and then you have the green point right next to the red point. So instead of saying a delta y over delta x, since those points are really, really close, we'll say a small difference in y over a small difference in x is the same. Delta y over delta x is sort of the same idea as dy dx. They're the slope, okay? Anyways, now that you have a brief idea of what it is and what it means, let's find some derivatives. So, activity 2 for, I think, section 3.1.2, I'm not sure. But the first one listed in the sheet, anyways. They asked to find dy dx. Right? So for part A, we have y is equal to square root of x. Now, we know rules, right? You have the power rule, the quotient rule, the product rule, and the chain rule. Those are the 4 rules that we have, and we have some properties, right? This one doesn't seem to fit any of the rules. So instead of saying square root of x, I'll say x to the half, right? They're equivalent. Now we can apply the power rule. So y is equal to x to the half, right? That means y prime is equal to Well, f prime of x is equal to dy over dx. They're the same thing. Is equal to, so you bring the half down, right? You write at x and then put half minus 1, right? Simplifying this gives x to the negative half over 2, right? Half minus 1 is negative half. Now, if we have, for example, 1 over 2 to the negative 1, we can bring this 2 up. This is equal to 2, right? So if we have x to the negative 1, this is equal to 1 over x, right? Similarly, if you have 1 over x to the negative 1, this is equal to x. Those are just some algebraic properties. Anyways, we can simplify this into 1 over 2x to the half, right? Since there's a negative on top, when I bring it down, it will be a positive half. Now, what's x to the half? That's just the square root of x, right? This is equal to 1 over 2 square root of x. So y prime, or dy dx, or f prime of x, is equal to 1 over 2 radical x. Now, this is something that you should memorize, okay? So keep a table somewhere in your copybook or something. If y is equal to square root of x, this means that dy dx is equal to 1 over 2 radical x. It makes everything so simple and it applies to all cases, okay? So you don't need to go through all this algebra every single time you need to do that. Alright? Next up, we have b, y is equal to, let's see, 1 over x squared. 1 over x squared. We can do the same thing. Instead of saying 1 over x squared, this is equivalent to x to the negative 2. Now, applying the power rule, we have y prime is equal to, bring the power down, so negative 2, x to the negative 2, the old power, minus 1, right? Negative 2, x to the negative 3. Now, x to the negative 3 is just 1 over x cubed, right? So we have negative 2 over x cubed, right? So that's dy dx, or y prime, or however you call your derivative. Now, moving on to c, we have y is equal to 1 over x. Let me just make sure. Yes, it is. That means this is equivalent to, instead of saying 1 over x, we have x to the negative 1, right? That means y prime is equal to, bring the power down, negative 1, x to the old power, which is negative 1, minus 1. That means y prime is equal to negative x to the negative 2. Instead of saying x to the negative 2, we can bring it down, saying that y prime is equal to negative 1 over x squared. Now, for the last part, part D, y is equal to, let me zoom in, we have x squared over radical x, right? Rewrite it a different way, x squared over x to the half, because we know that radical x is the same as x to the half. Anyways, we have the same base, we have x and x here, right? That means we can combine them into 1x to the numerator power, this thing comes here, 2, and then the denominator power, this thing comes here, this is minus half, okay? This is equal to x to the 2 minus half, that's 3 over 2. So we rewrote y is equal to x to the 3 halves. That means y prime is equal to, bring the power down, 3 over 2, x to the 3 over 2 minus 1 is equal to 3 over 2, x to the 3 over 2 minus 1 is 1 over 2. This is equal to 3 radical x over 2. This is y prime. Moving on to section 3.1.3, here we have activity 1, right? Now, at this point, there are many ways to evaluate derivatives. In the previous example, I showed you the power rule, right? In this case, I think all of them are done by the power rule and the polynomial property. But you can also do them using the, I don't know, quotient rule, product rule, but I think it's best if we use power rule over here, since it's simpler, right? And you always need simpler stuff in math. You always look for the simplest way to do, a question. Anyways, so we have question 1, a, y is equal to the square root of x cubed, right? We can rewrite that as x cubed to the 1/2 power, right? And whenever we have x to the power, we multiply those powers. So this is equal to x to the 3/2, right? Now, this is just a standard power rule. We have y is equal to x to the 3/2. Sorry. Better handwriting, please. Okay, that means y prime is equal to, bring the power down, 3/2 x to the 3/2 minus 1, which is half, which is square root of x. I'm doing them quicker because it's the power rule. I think you know it already from the last part. Anyways, b is important. Y is equal to the square root of 5/2x. Now, let's split the square root up. So it is square root of 5 over square root of 2 times square root of x, right? Now, we use another property called the constant multiple property. Square root of 5 is a constant, right? Square root of 2 is a constant. That means that, we can just leave them on the side and take the derivative that is not constant, which is square root of x. That means that y prime is equal to, we have radical 5 over radical 2, and then we have the derivative of, 1 over radical x, right? We leave all of this on the side, and then we evaluate this derivative. Anyways, so we have y prime is equal to, we have radical 5 here. Let me just combine the radicals. We have 5/2. Now, what's the inside? We have derivative of x to the negative 1/2, right? This is equal to radical 5/2. We have negative 1/2. This is multiplied by. Then we have x to the negative 1/2 minus 1, which is negative 3/2. This is equal to negative, let's see, how do I write this? Radical 5/2 radical 2 x cubed radical, right? I think you can verify that this is true, and here is your derivative. Now for part C, we have part C, y is equal to x squared over, let's see, we have the cube root of 5x. Now we know that the square root of x is x to the half, right? The cube root of x is simply x to the third. The fourth root of x is x to the fourth, right? And the pattern continues. So that's just some basic properties. Anyways, let's evaluate the derivative. How do we do it? We can split the the cube root is equal to x squared over, we have cube root of 5 times cube root of x. Now, cube root of 5 is a constant. We can leave that aside and take the derivative that is not constant, right? So we have y prime is equal to 1 over cube root of 5 times the derivative of the inside. Now, what's the inside? You have x squared over cube root of x, right? This is x squared over x to the third. This is equal to x to the 2 minus the third is equal to x to the, let's see, 5/3. So we'll be taking the derivative of x to the 5/3, which is, you should know this already, 5/3, x to the 5/3 minus 1, which is 2/3. Be writing this, we have y prime is equal to 5 over cube root of 5, that's right, 3 cube root of 5, how do you do it? Cube root of x squared, right? Because we have x to the 2/3. That's like saying x to the 2 to the third, right? Which is equal to the cube root of x squared. Moving on to part D, we have y is equal to the square root of 2x over the fourth root of x. Breaking up the square roots, we have square root of x square root of 2 times square root of x over 4th root of x. Square root of 2 is a constant. That means we leave that on the side and take the derivative of the non-constants. So we have y prime is equal to, let's see, what is square root of x over 4th root of x? This is just x to the half over x to the 4th, which is equal to x to the half minus a quarter, which is equal to x to the quarter, I think. Anyways, so we'll be taking the derivative of that. So leave the constant, right? Take the derivative, 1 over 4 x to the 1 over 4 minus 1, that's minus 3 over 4, I think. So it's equal to, let's see, square root of 2 over 4 x to the 3rd, take the 4th root. So here's your derivative, and let's move on to question 2. Now, question 2 utilizes the polynomial property, meaning that you can apply all of the rules, and then you can, but you can split them up. What I mean by that is, if you have a polynomial, right, you can take the derivative. So taking the derivative of this, let me get a better color, sorry, this, split them up into 5 functions in this case, right? Take the derivative of each and then add them up. Amro, as I said, he did videos on all of this already, explaining all this, proving all this even, using definitions, and it's very interesting and it's really helpful. Anyways, let me just solve this. Get white, please. Okay. A, we have y is equal to negative 5x5 plus 2x4 minus 6x squared plus x minus 2, a huge polynomial, right? But it's really easy to evaluate its derivative. It's y prime is equal to power rule, right? We have, initially we have negative 5, that's constant. Leave that on the side, and then multiply by the power rule, which is 5x to the 4, right? So in general, if you have power rule and a constant right beside it, just multiply this and that, and then subtract 1, right? So we have 5 here. So we have negative 5 times 5, that's negative 25, x to the subtract 1, which is 4, plus 8x cubed minus 12x plus 1, right? And the last part, plus 1, is because it's plus 1x, and the power rule on 1x, x to the 1, right? It's 1 times 1 x to the 1 minus 1, so it's 1 x to the 0, which is 1, right? Just so that you know. And the derivative of a constant is 0. Anyways, here's your derivative, and let's move on to part B. Let's see, we have a fraction this time. B. Y is equal to 4x 5 minus 3x4 plus x squared over 3x squared. Now, let's split this fraction, right? So we can compute its derivative. Y is still equal to, well, we have 4 over 3x cubed, right? How did I get that? I get that by, well, 4 x to the 5 over 3x squared, right? Combining those two x terms, we have 4 over 3x to the 5 minus 2, which is 4 over 3x cubed. Anyways, moving on, do that to every single term up here, 3 of them. Let's see what we get. We get minus x squared plus 1 over 3, I think. Right? Now, this is just a straightforward power rule. We have y prime is equal to, let's see, we have 4x squared minus 2x, right? Simple power rule. Let me explain this actually. We have 4 over 3x cubed, right? So we have 4 over 3, when you take the derivative, 3 down, x squared, the 3 cancels out, we have 4x squared. That's how I got the 4x squared down there, if you're wondering. Next part, we have, let's see, same thing. Let me just write it here. Y is equal to 1 over 5x5 plus 1 over 3x cubed minus handwriting, please. 1 over 3x cubed minus 3 over 2x squared. Okay, here's your y. Now let's compute y prime is equal to, we have x4 plus x squared minus 3x. I think so, because it's the same thing I explained here. We have this term, right? The way we compute the derivative, same thing, of course, power rule, but in this case it's simpler because the 5 and this 5 cancels out, and then the 5 minus 1 becomes 4. Same thing with here, and then in this case you have a 3 left out, so we have a 3 here. Anyways, that's, I think, part C, and we have part D. Part D, you can do it in many ways, to be honest. I think the easiest way is to just distribute. So we distribute, and then we have the 2x distribute into like all of them. Erasing this. Okay. Let's do part D. D, we have y is equal to 2x into x minus 3 and x plus 3, right? It's equal to 2x multiplied by, we have x squared plus 3x minus 3x minus 9 plus 3x minus 3x cancel out is equal to x into x squared minus 9. Let me just confirm that's correct. Let's see, should be. Anyways, this is 2x cubed minus 18x. This is still y. We didn't compute derivative yet. We just simplified it. And we take the derivative, simple power rule. We have 6x squared minus 18. And we're done, I think. 6x squared minus 18. We're done with, I think this is, let me check. I think this is section 3.1.3, activity 1, right? We still have activity 2 left, but I think I'll leave that for part 2 since it's getting long and I'm tired as well. So I hope this video helped you with the power rule the most. And in part 2, we'll finish this section and we'll continue on to the product rule and quotient rule.